about how to find areas of different things. We know in general, like, how to find the area of a rectangle, a circle, a triangle, those kinds of things. But if I just give you a curve, we need to be able to find the area under that curve. So that's what we're going to be working on. If I had this particular function, the first graph on your handout, let's say I wanted to find the area of that blue region. How would I go about that? So some general ideas, we could break it up into shapes that we know to kind of approximate the area, couldn't we? If nothing else, if you had this problem on ACT and you were trying to find an area, you would probably start looking at, what could I do? Well, I could, maybe look at this rectangle, and maybe I could kind of use a triangle here, or, start breaking it up into pieces. Is that going to be exact? No. Would it get you in the ballpark? Yes, if you did enough little shapes to be accurate. And we have some things that we could do. If we have polygons, we know we can break them into triangles and get there like that. But it's not going to be real accurate if I just start trying to break this into random shapes. So one thing that we could do is break it into a lot of little rectangles. So for instance, if I wanted to use like 2 rectangles to approximate this, I could find, if I did 2 rectangles like this, and found the area of those 2 rectangles. First of all, is that going to be a very good approximation? No. Could you tell me, would that be an over or an under approximation? Would my approximation be more or less than the true area? Over. Okay. What if I did more rectangles? How about I said, well, 2 is not very good. What if I broke it into 4 rectangles and found the area of all 4 of those and add them together? Still going to be over. Is it better? Yeah. Or what if I said, well, I want to be even better than that. So this time, let's do 8 rectangles. And if I start breaking it up into 8 rectangles, as I do this, what's happening to my estimation? Is it getting better or worse? Better. Every time I break it up into smaller rectangles, my approximation is getting closer to the true answer, right? So 8 is looking pretty good, definitely a lot better than 2, and I could even go to 16 or 32, or maybe the limit is it goes to infinity, those kinds of things to find that area. So today, we're not going all the way yet. We're not going to do the limits quite yet. But what we are going to do is practice breaking it into these rectangles to get an estimate for the area under our curve. Okay? All right, so here is our first problem that I want to do. I want to find the under and over estimates of the area under the curve f of x equals x squared on the interval 0 to 3. First, we're going to use 5 rectangles, and the key on this, we're going to do equal width on all of our rectangles. We don't want, one huge rectangle and then one really skinny one. They're all going to be the same width. The width of 3/5, because my interval is 3 units long, so if I'm dividing it into 5 pieces, 3 over 5. And then we'll do it with 10 rectangles with the width of 3/10. Okay, here we go. You could draw a picture to help you with this. Obviously, we know on our test we're not going to have a calculator, so these on a test I'm going to do a lot of set this up, but I'm not going to make you evaluate it and give me the final answer, because the numbers are just going to be too ugly for you to plug them in and work them out in your head. But the over and estimate, underestimate, a picture might help you kind of determine that. We know we're just going from 0 to 3. 0 squared is 0. 1 squared is 1. 2 squared is 9. So just a really rough sketch. We're essentially looking for the area under this little portion of a parabola. Okay. So if I am going to break that into 5 rectangles, okay, then one thing I'm going to have you do is find the change in x. I already gave it to you on this one, it's the 3/5, but it's basically your ending point minus your beginning point divided by the number of rectangles. It's the width of your interval divided by how many pieces you want. So this time, everything will have a width of 3/5. How do we find area of a rectangle? Length times width. Okay. If I am doing 5 of these, we will essentially have 5 things to add together. Okay. So my first rectangle, so it would start at 0, length of 3/5, it would go to here. So we wanted, let's do the overestimate first. So the length of this thing is 3/5. The height of this rectangle is measured by the point on the parabola. So how would I find that height? Plug it into your equation. Would it be easier? I don't care. We can work in terms of fractions, 3/5, or we can use 0.6 if you guys prefer decimals. Is that gonna, do you care? 0.6, is that better? Okay, so if I'm going to find my y, I would just have to put in 0.6 into my equation. So I'd have to do 0.6 squared. Okay, the next one. The width every time is 3/5. If I add another 3/5, what's my x value? So I'm essentially adding 0.6 each time. So I was at 0.6 to begin with, now I'm at 1.2 squared. Every one of these has the 3/5 because they all have the same width. To get my next value, we just have to add that 0.6 each time. We're adding the 3/5. So we're at 1.2. If I add 0.6, I'm at 1.8. If I add 1.6, or add 0.6, we're at 2.4. If I add 0.6, I'm at 3. Okay, first of all, is this the over or the underestimate? Over. A lot of times I'm just going to put an over with a subscript of 5 to show me this is an overestimate with 5 rectangles. In the future, I am not going to write this 3/5 every time. I did it on the first one just to show you, but since everything has the same width, you can just factor out that 3/5. So we're essentially doing 0.6 squared plus 1.2 squared plus 1.8 squared plus 2.4 squared plus 3 squared. Does everybody see how we got this? Okay. So now, for homework, we have calculators. Let's plug this in our calculator. I got 11.88. Now I asked for an underestimate with 5 rectangles. So first of all, how will my answer compare to the 11.88? It should be smaller, okay? The idea is, the first set of rectangles I drew by taking the highest point on the parabola. For the second set, if I'm starting at 0 and ending at 0.6, if I want the underestimate, I have to take the low point on the parabola. So my first rectangle is just this, which is nothing. The second rectangle is between here and here, so if you take it based off the low point, it would look like that. Your third rectangle will look like this. Your fourth one would look like this. Your fifth one looks like that. A lot of times these are sometimes can be referred to as left and right hand sums. The first one I use the right hand point on every rectangle. This one I'm using the left hand point. And you see this is an underestimate because all of these rectangles fall below the actual curve. So the setup is the same. The width of all these rectangles is still 3/5 or 0.6. But what did I use for my first x value? 0. So that one's 0 squared. We should have 5 of these because we have 5 rectangles. So the next one we use the 0.6 squared. Then you just keep adding your 0.6. So the next one was the 1.2 squared. 1.8 squared. 2.4 squared. What is the only difference between the over and the under? Which point? The first one, my over, had a 3 squared. This one has a 0 squared. The first and last points. Otherwise, everything else is the same. So if you just typed in the first one, you could just hit second enter and bring it back up. And instead of a 3 squared, we need a 0 squared. And this one gives me a 6.48. Okay, so is my true area either of those two numbers? No, but where does the true area fall? Somewhere in between them. Okay, if I do 10 rectangles, what should happen to my over and under estimates? They should get closer together, right? So it's giving me a better idea. All right, let's see if we can do this without drawing the picture. So for the over estimate with 10 rectangles, first of all, the change in x this time, we're just dividing it up into 10, so 3/10 or 0.3 if you like that. So I'm going to take 0.3, and then how many things am I adding together? 10. Okay, so for the overestimate, think about your first rectangle. We can either start at 0 or 0.3. Which one would give me a higher value? 0.3. So that's going to be where I start for my overestimate. So the first point would be 0.3 squared. And then how do I get every point after that? Add 0.3. So 0.6 squared, 0.9 squared. Do you guys all know why I'm squaring this? I'm just plugging it into my equation, which was x squared. 1.2 squared, 1.5 squared, 1.8 squared, 2.1 squared, 2.4 squared, 2.7 squared, and 3 squared. All right. One gives me 10.395. So my underestimate with 10, the change in x is still the same. What's going to change? The first and last point. So think about that first rectangle. It started at 0, ended at 0.3. For the overestimate, we plugged in the 0.3. What am I going to plug in this time? 0. And you just add your 0.3 each time. So 0.3, 0.6, 0.9. Where should this one end? 2.7. So if you've already entered it in your calculator, you just have to hit second enter, bring it back up. Instead of 3 squared, that last point is getting replaced with our first point here, the 0 squared. And we get 7.695. So we see those are closer together than our first 2 points. We know that the true value is somewhere in between them. So if I wanted to take a guess at the true value, what could I do with those numbers? Average them, add them up, and divide by 2. That would be a pretty good guess at what it looked like. If I wanted to get even better, what could I do? More rectangles. Do 20, do 40, do 50. How long do you want to be here? So you can get better just by making more rectangles. All right, let's try a couple more. So find the over and under estimate for 9 minus x squared on the interval 1 to 3 with n equals 8. So we could draw a picture if we wanted. You know, if we graphed this thing, the picture is kind of up to you, but it can help. My first point is 1. If I plug in a 1, what do I get out? 8. Next point, I'm stopping at 3. If I put in a 2, I get out 5. If I put in a 3, I get 9 minus 9, which is 0. So this time, like an upside down parabola, I'm taking that half, and that's what I want to find the area between. My change in x is your ending minus your beginning divided by the number of rectangles. So this is 2 over 8, so 1/4, or I usually think it's easier to work with the decimals. Let's just do 0.25. You can set it up either way, but. Okay, so for my over estimate, we're using 8 rectangles. Length times width, all these have a width of 0.25. This one's going to be a little more annoying to write because what do I have to plug it into? 9 minus x squared. Okay, so the first rectangle. Let's figure out, we could look at a graph to decide over or under, but let's talk about how we would do it without a graph. My change in x is 0.25, right? I'm starting at 1. So my first rectangle starts at 1, ends at 1.25. Which one would give you a bigger number if you plugged it in here? 9 minus 1 squared or 9 minus 1.25 squared? Which one's bigger? 1. So this time for my overestimate, I have to start with the 1. Okay, so my first point would be 9 minus 1 squared. Next one will be 9 minus, and we just add the 0.25, 1.25 squared. 9 minus 1.5 squared. Nine minus 1.75 squared. 9 minus 1 point, oops, if I add, that's just going to be a 2 squared, isn't it? 9 minus 2.25 squared. 9 minus 2.5 squared. And 9 minus 2.75 squared. Do you guys all see where I'm getting these? It's annoying to write out on a test or quiz. Probably gonna have to make you leave your answer there. So you will have to be able to write all that out because without a calculator, you would spend all day working this. That's not what I'm concerned with. But we have a calculator right now, so let's try it. I better not be the only person plugging this in, because I know how to put it in my calculator. I don't need to take class time to see if I can do it. Okay, so for the underestimate, we know, first of all, that my answer should be smaller than this. It'll still be 0.25. What will I put in for my first number? 1.25. And I'm going to be lazy, I don't want to write all this out. What's my last one going to be this time? It should be 3. Okay, one of them will use the left endpoint, one of them will use the right. So like my overestimate started at 1 and it ended just shy of my 3. The second one starts after my 1, but it ends on my 3. So if you typed it in correctly, the nice thing is you can just hit second enter, and instead of 9 minus 1 squared, I need a 9 minus 3 squared. So are you guys okay if I'm not writing out all of the numbers on this one? You guys know what I'm plugging in? Okay, please, if you need me to write them, just say something. And I got 8.3125 this time. So if you wanted to take a shot, you could add those up and get an average of them. Let's do that real quick. If I wanted to estimate it, add those up, divide by 2. So my best guess right now would be an area of 9.3125. Now, is that the exact area? No, but it's probably fairly close. Okay, let's do one more. Over and underestimate for 13 minus 3x on the interval of 0 to 3 with n equals 6. Certainly, if you want to graph it, you can. 13 minus 3x is just a line. If you plug in a 0, you get out 13. If you put in a 3, you get 13 minus 9, which is 4. Please don't graph as horribly as I do. I'm really skipping a lot of steps right there. Don't let any algebra once do something like that. Really bad. But we're just finding that area. So, first let's find our change in x. This one ends at 3, start at 0, dividing into 6 pieces. So 3 over 6 is 0.5. So our overestimate was 6. We'll do 0.5, and then we have to add 6 things together. So if you think about this, your first piece would start at 0 and end at 0.5. Which one will give you a bigger number? When you do 13 minus 3 times 0 or 13 minus 3 times 0.5? 0. So for my overestimate, I need to start with my 0 one. So the next one would be 13 minus 3 times 0.5. Add my 0.5, so 13 minus 3 times 1. 13 minus 3 times 1.5. 13 minus 3 times 2. 13 minus 3 times 2.5. Try plugging it in. I got 27.75. How will my underestimate differ? What will my first point be? 13 minus 3 times 0.5. And my last point will be 13 minus 3 times 3. So all you really need to do is change that first point and what did you get? $23.25. So on your homework, the level of work you show me is kind of up to you. Just make sure you're getting the right answer. If you're not writing everything down, then I don't have a lot of ways to give you partial credit. On the test or quiz, do as I say, not as I do. Write them out like the first one, not like the second one, because I'm grading you on that work, not the calculator answer, okay? So obviously we're kind of figuring out this is really time consuming, right? And we want to try to get a better method. We are not going to get there today, but we are going to talk about something that we will be using to find this better method later on, and it is summation notation. So this E-looking thing, it's the Greek letter sigma. It means you are going to find the sum of every term from 1 to whatever this number is up here. So, for instance, if I gave you this, that says find the sum from 1 to 10 of I squared. So your first number would be 1 squared. Your next one would be 2 squared. And when would I stop? At 10. So this basically gives you the first and last number you plug in, and then you do every integer in between. Okay? So if we plug those in, what do we get for our sum? $385. So the first section on your homework tonight will be things like this. I am on your homework and on a test probably just going to say write it in expanded notation. That means you don't necessarily have to find that sum because on a test you don't have that calculator. This will be your expanded notation. You're showing me that you know what that sum means. So let's do a few more. We'll go ahead and write them in expanded notation and add them up just for fun. From k equals 1 to 7 of k plus 1. So if I expanded that, the first number I plug in is 1. 1 plus 1 would be 2. The next number I plug in is 2, and we get 3, 4. What will be the last number? 8, because if you plug in a 7, 7 plus 1 is 8. And that should give us a 35, I believe. What does B look like in expanded notation? What would be my first number? 2. And then we would have 4. You can, I don't care if you want to write 2 to the first, 2 to the second. Or if you want to write 2 plus 4 plus 8, it does not matter at all to me. So you just have to have it in some form. So whichever way you choose. And And what does that add up to? $128 or no, 126? The last one is a little more tricky. Sum from j equals 1 to 5 of -1 to the j plus 1 over j squared. Okay, so we're going to plug in a 1, 2, 3, 4, 5. We're going to have 5 terms here. If I put in 1, 1 plus 1 is 2. What happens if you take a -1 and square it? It's a positive 1 over 1 squared, which is 1. If I put in 2, I get -1 to the third, which would be -1 over 2 squared, which is 4. If I put in 3, -1 to the fourth would be 1 over 3 squared. If I put in a 4, -1 to the fifth is -1 over 4 squared. If I put in a 5, -1 to the sixth is positive 1 over 5 squared. I'm not going to take the time to add this up. I just want to make sure you guys understand how to write these. Is that okay? Last thing I want to do today, last slide we're going to work on. I've given you this. I want to see if we can write a summation notation to match it. Okay. Sometimes there's more than one possible answer, so we just have to find something that works. So let's do the sum. Let's just start it at 1. What would we end at? 6. Okay, so this is my first, second, third, fourth, fifth, sixth term. So these are all just i's, but what's changing? The sign. We just saw in our previous example, to change the sign we need -1 to a power, don't we? Okay, so if we just did -1 to the I power, that would make the first number I put in negative, but I need it to be positive. So what should I do to my exponent? Add 1. Okay, so then if I put in a 1, I get -1 squared, which is a positive. If I put in a 2, I get -1 to the third, which is negative. How would I just get my number 2? Times I. So then if I put in a 1, let's see if it works. -1 squared times 1 is 1. If I put in 2, -1 to the third is -1 times 2 is -2. If I put in 3, -1 to the fourth is 1 times 3 is 3. So does it work? Yes. Okay, B. I should start at 1 and end at 5. We only have 5 terms. Sometimes it's helpful if you can write all these things looking the same. All of them are fractions except the first one. But 1 is the same thing as 1 over 1, isn't it? So if we look at what all these have in common, they're all 1 over something. The first term is over 1. The second term is over 4. The third term was 9. The fourth term is 16. Fifth term is 25. So what do I need to do? I squared. Okay, last one. This looks pretty ugly. How many terms do we have? 9, so we need to go from 1 to 9. Let's try to write these looking the same. So some of these have radicals, and there's no way to rewrite that. 1 would be the same as the square root of 1. 2 is the same as the square root of 4. 2 radical 2 is the same as the square root of 3 is the square root of 9. So how would I write this? Square root of I. We are stopping there for today. I did post a handout on Classroom. I apologize. I know it's not quite as much time as I normally give you to work on things. So so I do apologize for that. But I feel like we've had a lot of class time lately, so it's okay to have homework every now and then, right?